Welcome to the presentation of our new product CAN Basic, a training board concerning CAN bus Teknik. We begin with the basic build-up of a CAN bus network. The scheme shows a vehicle with its light system. A conventional wiring is shown. Every lamp is directly connected with a switch or brake contact. Now the same functionality is shown with CAN bus Teknik. The front and rear lights are connected to control modules. The control modules are connected parallel with the same 3 bus wires. This small example shows that the cabling effort is reduced. Further, the control modules can detect defective lamps and can inform the vehicle driver. The shown vehicle view contains 4 control modules and represents exactly the build-up of the training board CAN Basic. In the following, the 4 CAN nodes are described. The front node controls the front lights. The alarm node supervises the vehicle inside. The main control module connects complete vehicle system to diagnostics. The rear node controls the rear lights. On the training board, you can see the routing of the 3 signals supply, CAN high and ground, connecting all 4 control modules. In original vehicles, you need an OBD to USB converter to connect the main control module to a PC with diagnostic software. The CAN Basic board already contains an OBD to USB converter and can be directly connected to a PC. Power supply of CAN Basic board is taken from USB bus, so no further cabling is necessary. The bus wires are used to transfer multiple data information. How does this work? The data are transferred consecutively. Here's an example. The man with a lamp, the transmitter, wants to send some information to the man with a telescope, the receiver. He wants to transfer data. To do that, they agree on that the receiver saves the status of the lamp every 10 seconds. This looks like that. Now 8 data bits have been transmitted with a data rate of 0.1 per second. This is called a serial data transfer. For use in automobile applications, the time interval is reduced from 10 seconds to 6 microseconds. To transfer the information, electrical voltage levels are placed on the data bus wire. To measure the electrical CAN signals, an oscilloscope is used. 2 test pads on the CAN Basic board allow the measurement of the signal. To show the complete CAN message, the oscilloscope resolution has to be decreased. The result is that the single electrical CAN bit levels cannot be recognized anymore. To solve this problem, the CAN basic module is equipped with a digital storage oscilloscope. We insert CAN basic module in a free USB plug and it will be automatically detected. The CAN basic software can be started now. You can see the software view reduced to the oscilloscope view with attached bit values. The red marks show the data transferred in the previous example. To explain the other elements of the CAN message, we colorize the CAN frame and attach it with description captions. Every colorized part of the CAN message corresponds to an input field with the same color. The red marked area contains the user data information, which can be set in bit, nibble or hex nibble format. The yellow area defines the user data count. The unique identifier can be set in the green area. The blue area allows to set the CAN message to remote. That means that a response from another CAN node is expected. Many CAN bus systems are protected against disturbance with a second data via CAN low, that is an inverting of the CAN high signal. Six consecutive bits with the same level defines the end of a CAN frame. By coincidence, other parts of the CAN frame can contain more than 5 consecutive bits with the same level. To avoid that these bits mark the end of the CAN frame, an opposite bit is inserted if 5 consecutive bits with the same level appear. These bits are called stuff bits. The CAN receivers ignore these bits. With the input fields, all data of a CAN frame can be set, and so every CAN message can be sent. The inserted data are immediately refreshed in the CAN frame. In this example, the data length will be changed from 1 byte to 8 bytes and back to 1 byte. The description text shows that the turn signal will be controlled with ID 2C1 and data bit 0 and 1. All data bits are reset to 0. The ID is set to the value 2C1. To activate turn signal, data bit 0 or 1 has to be set. In automatic cockpit mode, you can control complete module with simple mouse clicks. CAN data are set automatically according to the desired actions. The turn lights can be set to low beam to work as running lights. Brightness will be controlled by pulse width modulation according to modern LED technique. Now we activate low beam headlights, fog taillight, brake lights and high beam headlights. With deactivation of driving lights, the fog light is also deactivated. The control logic of the CAN basic light system is according to Volkswagen vehicles. The features ignition and coming home are also included.
With Alarm Node, you can read out a sensor signal after a preceding initiating remote request.
In remote mode, a second CAN frame will be received and shown below the sent CAN frame. The CAN data byte now contains the measuring result of the sensor. With approximation to the sensor with your finger, you can change the measuring value. The pause key freezes the current CAN frame and allows exact analyzation. As already shown, different parts of the CAN frame can be hidden. Further, a hiding of each bit in the CAN frame is supported. This is very useful if you want to use CAN frame view in your own documents, for example in an exercise sheet.
The presentation of CAN Basic board is now completed. As you can see, this training board is a real competitor of 100 times more expensive training equipment based on original vehicle parts. And more, the following features you cannot find anywhere else. Inbuilt digital storage oscilloscope with automatic trigger. Real-time view of CAN frame with detailed description. Direct graphic assignment of CAN frame and electrical CAN signals.
We hope this product is of interest for you. Please use our offer to evaluate the complete product with our free evaluation kit.